everyone says hi. We were going over number 13 because they had questions on that from homework yesterday. Sorry. But we are going on to section 9.3, but I figured I was just going to talk out 13 real quick. George has one solution or one way of looking at it on the board. But I was just going through, just reminding all of us what this really means, and George kind of used this, just used it in a shortcut fashion. Remember, when you're adding exponents, you're multiplying like bases, and you're putting those exponents together with addition. The reason why we want to split that up is because if you look at this initially, you might just think like, hey, either the bottom wins. Maybe you would think that because of the n+1, which is a faulty conclusion. Or you might think, hey, the degrees are tied because they both have just an n, so therefore it's 1, and that's a faulty conclusion as well. The best way to look at this is to go ahead and realize or rewrite what's going on with that addition and the exponent down below. Then you can go ahead and see, yes, they are tied, but the ratio of the leading coefficients, just for simplicity's sake, not using L'Hopital's, using the degree test, you can say the ratio of the leading coefficients would be 1/2. Therefore, by, what were we doing, divergence test? Or the nth term test? So by the nth term test, oh, that's true. By the nth term test.
You didn't put this in 0.
Yeah, I'm getting it. It's not showing on my screen, sorry. I have to like zoom in, zoom out to see everything. The limit does not equal 0, therefore by the nth term test, the series diverges. Dun, 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 dun. So hopefully homework wasn't too bad. Geometric was okay too after the worksheet that we did.
Yeah. There was only one, I think.
Oh, there's only one anyway. Okay. When we come back into here, did you guys finish our examples from yesterday about the divergence test?
No.
What?
I don't know how
I
to do
did
that.
all of them, I think, except for.
Just for sake of time, we're just going to go ahead and just talk about the limits because that's enough, right? And then you guys have practiced in homework and in our examples yesterday how to write in order to be retaining what you're learning. This particular limit as n goes to infinity of 2 to the n, right? What do we got? 2 to the infinity, which is not 0 to the infinity, which does not equal.
0.
Is that cool? So therefore, what does it do?
Divergence.
Yeah, okay. By the nth term test. Number 5, what's going on?
0.
Oh, struggle. The limit as n goes to infinity of e to the 2n all over n factorial.
Bottom win.
Why is the bottom win?
Factorial is fast.
Why is n factorial faster?
Because it's faster.
Why?
It's the other one faster than 8.
Yeah.
But why?
Because it's
Because
multiplying
you
all
told
of
us
them.
so.
But why?
You explained that.
But why?
Isn't it a special limit?
Because you're multiplying by.
Why am I going to last chapter?
Because you told us last chapter. And it's in
Why am I going to the sequences and the limits and all that stuff section?
That's where it is.
Yeah. Don't we have an Endeavor card back there?
Hmm?
Yes, Endeavor card is all up to date. Endeavor
There's
card's
something
all
like
in.
special limits, right?
Where are they? Ooh, sequences. Hey, that looks like our worksheets. That's for a reason. What do we know?
Bottom wins.
Oh.
Whenever we have a factorial, and whenever we have an exponential, which this one is x to the n, isn't that even
More.
e to the n, x to the n? Remember, the n is the exponent. If we have something exponential with a variable in the exponent and then something factorial, who wins? Factorial. So then coming on back, e to the 2n over n factorial, bottom wins. The limit is 0. What should we be able to say?
You know nothing.
It's not geometric either.
Series may or may not.
The series may or may not.
Check. Yeah.
So now,
Yeah, it's not. It's not geometric.
Wait, why did George just say I checked and it's not geometric either? Because just because we know nothing by the nth term test we should still see if it's geometric because then we'll know something. Number 6, what do you guys say? What's the limit as n goes to infinity of n factorial over 2n factorial plus 1?
1/2.
1/2.
Not equal 0.
Why is it 1/2? The degrees are tied. Who needs to take derivatives or L'Hopital's, right? So we have 1/2. 1/2 is not the final answer. The final answer is that is not 0, right? So therefore we say the series diverges. Moving on down to the bottom one. What's the limit? As n equals, nope, goes to infinity of 1 over n.
0.
0 is 0. So now what do we say?
You have to see if it's geometric.
Check to see if it's a geometric. Good idea. So let's go ahead and take them and say, hey, it's 1 over, we start at 1, right?
No,
1 plus 1/2 plus 1/3 plus, is it geometric?
No.
No. So right now, technically, with official test, can we say anything?
We can say we know nothing.
We can say we know nothing, or we can say, hey, this isn't with an official test. Miss D has talked about this one, and this one is a special one that we think might converge, but in all honesty, does it? No, it's called the simple harmonic. It never converges.
Why does it
It diverges. It increases.
Won't eventually the numbers be like negligible? One.
Okay, hold on. Wait. The limit of the sequence, the terms of the sequence are negligible, approach 0. But the sum is forever expanding in a way that the entire thing actually diverges. It's called the simple harmonic series, but it's not very simple at all. We'll be able to prove it with another test. I know it doesn't make sense. That's why these ones are hard. We have to reorient our brain as to what makes sense or not. Meaning, to a kindergartner, does a derivative make sense?
No.
No, but might it eventually?
Yes.
Maybe if you keep doing your math.
Okay, I said might it. Meaning, you were kindergartners once, so the answer is yes. Okay, so, moving on.
I would never.
Yeah, I think George skipped.
Ready, set. Right.
That's a hard question. I came out as a first grader.
Be smart, but are you smarter than a
scarred
third grader?
I
I'm
scarred
really
my
trying
mouth
not to make a
blood.
joke right now. 'Cause it was
That's
really
right.
funny.
Do it, Miss D, do it.
Let's do it.
Just do it.
Just
Miss D,
do
do
it.
it. Do it.
Oh, it's fast.
You're always here.
Even George must be
Hey,
here.
dude.
It wasn't a fat joke, it was the size of Jordan's a baby joke.
I was big.
See, that's what I'm saying.
I almost killed my mom.
God.
Okay, I was.
After I came out, she was not allowed to move, otherwise her blood pressure would spike
Are
and
you
she would die.
serious? Was it a natural birth, Georgie?
No, it was a C-section.
Oh, okay.
So I can kill
I had to be a C-section too. I was 10, 11.
I got someone who was 13 pounds.
My dad was 12 pounds and he wasn't a
I'm
C-section.
hoping C-section.
Right? I'm hoping.
Also third kid, so probably.
Oh, yeah, at that point.
My dad was like 4th kid, 12 pounds, and he was not a C-section.
Well, how were there
Nice.
C-sections right now?
One heck of a mom. Alright, so.
Like, how long have they been doing C-sections?
For a while.
Well, obviously they did it with me.
For a while. They called the midwife, they were doing C-sections back then. I'm sure they were more risky though. Sam, would you mind getting the creamer from the front table?
Risk it to get the biscuit, right?
And put it in my fridge.
What,
Georgie?
Yeah, risk it to get the biscuit.
I'm not sure if I want to compare childbirth to making biscuits, but
Well, if you make the baby a biscuit, if baby equals biscuit, then you gotta risk it to get the biscuit.
that's exactly why it's disturbing, Georgie.
You don't like biscuits?
I don't like making babies biscuits.
How about making biscuits babies?
I guess that could make sense. A really good biscuit, you might want to
Yeah.
rock it just a little bit.
Right in my mouth.
No, this just got disturbing. It just got.
Does that mean we shouldn't watch Alice in Wonderland?
What does that have to do with biscuits and being babies?
Why did you not like that version?
Which one? The
I
one
imagine it's
without-
horrible, but
I didn't see it. Joyce, by the way, they're writing notes theoretically.
I didn't really see the first, like, the cartoon version.
Do you guys see my every time you do this, a red panda dies poster that Josh Larson printed out for me?
oh yeah,
What are you doing?
I wanted to get a closer look at that, but
What are we
Every
doing?
time you don't do a plus C or a Yukon.
I thought that killed Ryan.
Yeah, I was looking at it.
Yeah, but that was his in between. He was impatient and he wanted to put a sign up.
I'm just killing.
This is the more formal one, but we'll leave the Ryan one up there.
I'm just finding any excuse Is Richmond not here today?
He's coming 5th period, hopefully.
Will you be here at lunch?
Probably leaving it, or right after.
Okay. Should I just talk to him tomorrow then?
What's up?
About, we have 2 extended lunches plus, food day plus another day that we wanna talk to
You
him
should probably talk to him whenever, as soon as
about. There you go.
Is it proper to write the series like that?
Let me see.
Like that?
Yes, that's one way. Like in mathematical type, even for integrals, one way puts them on the side because it's easier with programming language, and one way puts them like smaller below and above, which is harder with programming language. So
So if I write it on a piece of paper like that, is that fine?
it would be okay.
Okay, cool.
And I've gotten really good at drawing the little E's.
Yeah.
I know, isn't it fun? I like.
You have to do them really small to fit on top of
Yeah,
them.
you see, that's why I hate it, so I'm gonna start writing it on the side.
Really? Mine's good.
Okay, thanks. Please teach us a lesson on writing signals. Is anybody else frustrated with the government? I don't know how to balance it.
Yes.
I don't know how to
I was trying to give solutions to Zach, but I realized after with the fifth solution that she really doesn't do anything with the budget. So it means it makes no sense to keep telling her.
Right.
No, I'm just gonna call it that.
Or what we could do is stop borrowing and start paying off.
You can't stop it.
It's too
Unless you're gonna raise taxes by like 50%.
I'm gonna just give 100% of their money.
Even that would take like 3 years.
Everyone gave all their money, and in 3 years, you paid off. That doesn't sound too bad, actually.
More.
Where are you getting food? Where are you gonna pay the doctor?
Let's just not.
But you guys see exactly what the government is struggling with.
Yes.
Either make the people really hurt right now and actually give our country and the next generations a future, or
Well, you
avoid
don't have
pain.
to hurt everybody.
No, literally, you have to hurt everyone.
No. You see, what we can do, in my opinion, is
Just keep taxing the
whatever
rich more and more and more.
No. Is invest our Social Security, what we have little left in mutual funds, in American companies. Therefore, we're putting money back into the economy.
Okay.
And then we lower taxes on manufacturers, so manufacturers will come back, raise tariffs on foreign imports,
Okay.
and then that way Americans will have to start working in America again. That'll raise the economy, put more money back into people's pockets, have more jobs, and eventually we don't have to raise taxes because we'll have more people working to pay taxes. See
I
what
don't
I'm
think
saying?
I don't think the government's allowed to invest in mutual funds.
They've done it before.
Alright,
They wanted to invest the Social Security into a stock, and then the 2008.
yeah.
So they didn't, but they borrowed money from Social Security, which ended up ruining it because they couldn't put the money back.
Now the economy's in the hurt.
So we could just be hurting, kind of,
Those who like foreign goods.
those who, yeah, basically.
Well,
Big
we'd be raising
corporations that-
prices because if everything was, if foreign goods were more expensive than American goods, we'd have to rely more on. But then we,
In turn, eventually it would work out, right?
yeah, eventually.
Eventually. So we
And
would be
possibly we
raising
wouldn't have to be
prices.
hurt as badly as literally soaking everyone right now.
Right. And then that would expand the company so they would be able to make more plants or whatever they want to do. That way they can hire more people, you know?
You know, we could just take all the money that the government takes in taxes and just start putting it towards that debt.
We can't. Two-thirds of the money they take from the debt, or take from taxes, has to go to pay, what is it? Veterans, well, that's 1/3 of the 2/3 goes to pay Social Security and Medicare. The rest of that has to go to pay for veterans pensions, other pensions for federal workers, and stuff like that. Federal wages and all that. 1/3 of all the money we bring in goes to everything else that we have to do. Paying the debt, and we can't.
If we just take that 1/3 and put it towards the debt only, wouldn't it be better than putting only
No.
a third of
Yeah,
the
because
third?
then what happens to our military? We have no military. What happens, like,
And then we'll get invaded and we'll have nothing done.
Well, I mean, no one's gonna invade us because
Well, they would
It's
if they
just- it
realize
leaves
we're not
us-
paying for a military.
Exactly.
I don't think that, because don't we have an agreement, what is it called? The Geneva
Do
Code?
you really think anyone's gonna follow
Well,
that?
we've been doing it for a while.
I don't mean necessarily like specific organized countries. I was meaning more
Oh, you mean like
the
uprising?
terrorist groups,
Oh,
etc.
terrorist.
You know what I mean? Like they don't operate by the rules.
Fair, because when Bush lowered taxes and then we were getting less money, then they attacked us.
Well, I don't think that was because of that, but I feel like that did damage.
Yeah, I did. Yeah. It was rough. Are you still recording?
Yes, she is.
Okay, so that way.
Okay,
when
Joyce
it
gets
comes
to be a
out of it,
part.
I can just come.
All right, you guys ready?
I can come back and go after them.
Joyce, you probably don't need to listen to any of this.
You can for your own entertainment.
She already heard it. She heard it in Gulf. Literally, I was yelling, not yelling at them. I was giving her the same
It's a
solution.
civil debate.
And she was saying it wasn't gonna work, but I don't really know. She's an economist, so I have no idea.
Yeah.
She
I
probably
mean,
knows more.
I'm sure that'd be a really great discussion. Like she would love to have that discussion with you at more like, because then she'd be able to actually argue like her point as to why it would or wouldn't work. You know what I
I
mean?
mean, she does, like ish, but I don't understand it because she is smarter than me.
Just text her separately.
What?
Just
That's
text her
brutal.
separately, bro.
Okay, every time I bring up that group chat we have, my parents get on my case like, you have your teacher's number? That's so weird. No, do you have any idea how weird that is? My sister can tell me too.
Why do
So
you bring
it would
it
be
up?
weird, because we have some pretty funny conversations on there, and I get a kick out of it, and so I tell them the stories.
Gerardo, I don't think we have conversations. I think we just ask how to do things. You may be having conversations, but in reality, I really ask you that.
What's today?
Wednesday. Oh.
Okay.
Oops.
Okay.
See, we should be more,
Precise with what I'm asking.
what are you asking? Today is the day. Today's Wednesday. Today's Tuesday. Something.
Today can be all sorts of things.
Today,
Okay.
the day-
Integral test.
You guys feel-
I think we sent this so much this month, and last month.
You guys need, here you go, Sam, can you copy that?
It didn't work. I don't want some.
No, but Bailey's gone for half.
Oh no, that's in.
That's technically racist to white people saying that all white people have bad teeth.
Oh my gosh, you can't be racist to white people.
Well,
Yeah, I can do that.
why do I have two?
You don't. One has to go, one has to go.
No way, if you were to say that, it's not actually a test.
What conditions need to be true? I mean, I don't care.
Care about the teeth.
What conditions need to be true for the integral test?
It has to be continuous, positive, and
Ooh, continuous positive decreasing. How do we figure out continuous? Definition of continuous. Positive.
if it's positive.
Decreasing. If its derivative is
Negative.
ooh, for all numbers.
Ooh, I was helping someone.
For all positive numbers.
F prime and F double prime looking at grounds. It was an FRQ for AP.
Nice. Go team.
I'll have to figure it out.
All right.
And I was doing it over text, which makes it a lot harder.
Oh, that makes it so much harder. You do FaceTime or something. I don't even know. Okay. There we go. Compare. Now, hold on. Compare, right? Compare the infinite series with the infinite integral. Does this say that they are the same thing? No. But we are going to use the infinite integral from, or the integral from 1 to infinity of f of x dx to help us make some determinations, hopefully. If the integral converges, then the series converges, and if the integral diverges, then the series diverges. Why the integral test is nice is because it tells us about convergence and divergence. Geometric series tells us about convergence and divergence. The nth term test only tells us about divergence, hence why it's called the divergence test. Integral test tells us also about both. Okay? However, is every function always easy or even possible to integrate? No. So this is another test, but it's not the end. This is endeavor number, where were we at?
Oh, I got it.
What was
14.
the
We're on 14.
14? Use this test when f is easy to integrate. This test only applies to series with positive terms, or maybe another way of saying it,
So it can't be one of the plus minus plus.
or exactly, eventually positive only. or eventually positive only. What do I mean by that? A series might start. A series might start negative and then turn positive only, and technically that is okay. We are allowed to deal with those. But an alternating series like -1, +1, -1, +1, now obviously we wouldn't need to do integral tests with that because that one, it diverges, right? However, it's just one of those like, hey, it's a heads up. I'm trying to make it so you can see it. Can you guys see it? Eventually positive only. So you must check the 3 conditions first. Continuous. We already said definition. Continuous, positive. Okay, we just have to check the terms. So this might be one where you might want to expand just to make sure you know what's going on. Especially if it's something you're unfamiliar with, like trig. Decreasing. You have to think if the derivative is negative. But I was telling Amanda, I think, was it this morning? How I have never seen, oh yeah. And Sam, correct me if I'm wrong on this too. But I've never seen an FRQ require you to show all the steps as to why a series converges or diverges. Right? Weren't those all multiple choice questions?
Yeah, mostly.
Taylor and McLaurin showed up in the FRQs, but I don't think convergence divergence does. Not that I've seen. I still want you guys to be ready, and I need you to think through the process so that you can go ahead and justify in the sense of in your mind what's true and what's not. But I'm not telling you guys this to say, hey, you have to take the derivative every single time, because that's just going to be a lot of work. But what I do want you to realize is when you check the terms, if you can tell it's going to continue to decrease and never change, that's enough for me, okay? But if you can't tell, maybe you need to find a derivative and make sure that it's strictly negative. Is that cool? So let's go ahead and go play with examples. These are technically in your worksheet if you don't want to write them down. Otherwise, you can write them down in your notes. Focus, 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 new stuff. All right. Question. Is this a geometric series? I don't know. How do we find out?
Do the first couple terms.
Exactly. Plug in 1. You guys double check my work. Sam, you can double check my work too.
Wait, what can we
2 over 5. Hold on. 3 over 10. 4 over 17. Okay, we've done the first few terms.
Doesn't it appear?
And not even appear, how can we tell for sure? Do you remember? Geometric, you have to be able to say that the proportions are equal. True? The proportion of what gets multiplied from 2/5 to, or from 1/2 to 2/5 has to be the same thing as multiplied from 2/5 to 3/10. Question, are these equal? No. Because we'd end up with those would multiply to be 4/5. These would multiply to be 3/20. Is that the same? No. So what does that all prove? There's no common ratio there. It is not a geometric series. So, okay, can't use that, right? That's disqualified. Georgie, you were thinking maybe about the limit, right? Okay, limit as n goes to infinity. It's always a good thing to start with. But I already looked at it, and what's the limit as we go to infinity? 0. Struggle. Nothing. Okay, so does the nth term test work?
No.
Nope. So now what are we going to do?
Compare. So you have to check
The integral test, right? Okay, so we tried the nth term, it didn't work. We tried geometric, it didn't work. Integral test. I'm just trying to label it so you guys clearly see our process, right? So what does the integral test say? Considering the integral from 1 to infinity of n over n squared plus 1. Wait a minute, we don't use n's in integrals, right? What do we use? Okay, so let's go ahead and just simplify our process just a little bit. Limit as x goes to infinity. Why am I saying x? Improper integral b, right? Of x over x squared plus 1. Okay, is this possible to integrate?
Yes.
How? Use that.
Why isn't this one of those shortcut ones that you chose? 1 over p minus 1?
Oh, you're talking about the geometric too?
Because p series only, well, number one, we haven't talked about the p series. We talked about the limit. But p series is strictly for a constant over x to the power. This one has a variable over x squared plus 1. What's the answer? But don't worry, Jordan, the second half of the section, meeting tomorrow, we're going to talk about the p series test, which tells us what we are allowed to do. So we have u equals x squared plus 1. We have du is equal to 2x. Can I just move the 1 half to the other side? X dx. So then we can go ahead and say, hey, that's going to be the limit as b goes to infinity of, does that work?
Yes.
So then we can go ahead and say that's ln of u, true?
Yes. Ln is absolute value. You want this.
X squared plus 1 is always positive, yes, it doesn't matter. We're going to go from 1 to b, which is equal to the limit as b goes to infinity
1 half or infinity minus
ln of b squared plus 1 minus ln of 2.
Do we have to take ln? Or can we just say that goes to
Why does it go to infinity? Now, Gerardo, it is quite slowly. But see, just because the limit of the integrand is 0, we cannot say the integral converges. Does that make sense?
Yes. Series divergence.
So then we can say, wait. By the integral test. Why did I switch? Because by print was taking too long. By the integral test, since the integral from 1 to infinity of x over x squared plus 1 dx diverges.
Can we try div for diverges or?
Sure. The series diverges as well.
SD.
Yeah.
Do we have to check and see if it's
Ooh,
positive and
snap! Good.
no?
We did narrow down, it couldn't be geometric, it couldn't be nth terms, so then kind of by description, you assume we were able to use the integral. Thanks, Georgie. But what was the one thing that we should have done before we ever started the integral test?
Tested if it's suffice.
Question,
But
is
I don't know if it's-
this continuous?
Yeah.
No, it has a denominator, just kidding.
But it's
Can that ever
squared.
equal 0?
No.
No, so continuous, we can say,
Yes.
check. Is it always positive?
Yes.
Look at the terms, check. Is it always decreasing?
I
Uh-oh.
don't know.
Oh, we have to take the derivative and do a sign chart? Wait. What's 1/2? 0.5. What's 2/5? 0.4. What's 3/10? 0.3. What's 4/17? What's in
Less than 0.3.
0.25-ish, right?
Sure.
So if you can tell clearly it's going to continue decreasing like this one, then you're okay. But guys, you have to make sure to go through a few terms first. Some series increase for a little bit, then decrease for a little bit, then increase. So we have to make sure that we are accurate. Otherwise, if we do a test when the conditions aren't met, we're going to make a faulty conclusion. Does that make sense? So as you guys can tell, we can't just trust our logic on these. So what are we going to do in number 2? The integral test as well. Okay, those we do have some more examples, and then we're going to see another test tomorrow, the P series test, which is another nice and easy one. Integral test is a little bit longer because you have to integrate the improper integral, obviously. You have to solve the improper integral. But it's nice because, once again, it does tell us about both convergence and divergence. So we're still in the nice test phase. This is just a longer one. Does that kind of make sense?
Yeah.
Alright, okay. Let's go ahead and we're done, right? Like 5 seconds done? Okay.
Did I give my own one?
No.
Or was that it?
Nope.
What? We have a whole nother minute? Okay, you guys go. Do the next example. We can talk about the basics first. We won't check it until tomorrow.
Oh no,
Um,
this is arcane.
What is it?
Arcane.
Yes. Number 2 is arctan because it's 1 over u squared plus 1. Now that makes it easy, right?
I never learned.
Because a is just
Oh,
1,
no, no.
so it's 1 over 1 arctan of n over 1.
Oh, it's not. I thought
Oh,
you
yeah,
said
you
so
know,
for a
that's
second.
not
I was
decreasing.
like, I don't know that.
It could be, but no, it's not. And on the
Oh yeah. It's not decreasing.
is it?
No, it's not.
What do you mean it's not?
It's not decreasing.
What do we have? 1/2 plus. Yes, it is. Yes, it is.
So 1/2.
1/2 plus
One
1/5
fifth.
plus 1/10 plus 1.
That's definitely decreasing.
The denominators are getting bigger, but the fraction, the
Right, right,
decimal is getting smaller.
No, I'm talking about the integral.
Oh, no. The sequence has to be decreasing, not the integral. The integral comes next. Sorry. The integral comes next. Does that make sense, guys?
Yeah.
I want to. Kind of.
I'm trying.
Are you gonna be here, Misty, after?
I'm planning to be here until 4:30, something like that.
Dang it. That means that I have to actually take my clothes